this isn't the time to be messing around. I've spoken to you a number of times about this. Now, last week we stood right here and I made it very, very clear that when you're dealing with histograms, the area is proportional to the frequency. But each and every time that you're dealing with them, you make the area equal to the frequency. Now, sometimes that is true. Now, I'm going to write it large on the board. Now, stick it in your mind. Area proportional to frequency, not equal. It's dead easy. Is that an equal sign, Dr. Young?
No, sir.
No. What sign is that, Mr. Barker?
It's a proportional to sign, sir.
That is a proportional sign. Do not make that mistake again. And by the way, I watched last week's video. Just because I was sat out there on the corridor, I did not appreciate being referred to as an outlier.
Sorry, sir.
I'm not the butt of your jokes. Now that'll be the end of it.
Right, I've had a quick word with Mr. Dawson. He's had a word with me in his office, and I think I've got things sorted for this. I found this example just lying around in the maths department, Doc. So it's a graph showing the number of cardigans bought by maths teachers, and we've got some age ranges. Okay. Now you can see, initially looking at this, you can see this age range. They seem to have bought twice as many cardigans as this age range. But I see there's a problem with it.
This group's quite wide, isn't it? Like 50 years, where this one, it's only 10 years, isn't it? But this is the same width as this.
Yeah, so what Dawson said, he said, right, okay, don't focus on putting your frequency up here, draw a new graph and make the areas the frequency. Okay, so what I did, I got some just graph paper and I've gone from 15 to 75, which was all the age ranges. The first group went from 15 to 65, and the last one's 65 to 75. Okay, so if we go back, there were the two age ranges there.
Okay, I see.
So that now it's a lot wider. So what we've done, we need to make the area. So I'll work out with a nice easy one. This is 100,000 for this thing. So that's the frequency of that one. So I want the area to be 100,000. So I think, well, it's 10 wide.
Yeah.
So if I make it 10,000, 10 times 10,000, like 100,000 for the area. So I quickly went up and I was doing it in thousands. So there was like 2,000, 4,000.
6,000.
Yeah, well done, sir.
Right.
10,000, like that. Okay. So if I go across, I can draw this bar in. All right. Do you want to just finish that bar for me, sir? Oh well. Now, obviously, I can fill in the scale a bit more. So we've got. That went well. Now, over here, we want to find this one here. So we've got 50 across on this one. Okay. So I thought, well, 50 times something to make 200,000. Well, I can just divide it and do 200,000 divided by 50. I could do like 200 divided by 50 and stick the thousands on, so it'd be 4,000. So this one should go up to 4,000, which is there.
I think you'd better draw this one, sir.
Yeah, I have to be careful because 15's there, so I don't want to put that one. Yeah. Okay, so you can see now it's a much better picture. We've got the area is the right thing, well, in this case 200,000, so there's more people here buying here, but this age range is much smaller, much narrower.
Okay.
So it looks like all those retired maths teachers buying a lot of cardigans, or Mr. Anthony maybe. Right, okay, well let's have a look here how you can generalise this a little bit.
I mean, I agree with what you've done, but I'm pretty sure Mr. Dawson said that that we weren't meant to make the area the same as the frequency. Now, if I've understood this right, the area of this would be 100,000, and that was the frequency. I thought you said not to do that.
Stick it in your mind. Area proportional to frequency.
Oh yeah, well I think at GCSE it was like the same, but I think now on a handy like prepared slide here. A GCSE area is the same as frequency,
Oh, right.
but slightly changed. The area is k times frequency, or area is proportional to frequency. So, for example, on our thing, an example, we can get rid of maybe the thousands. Okay. So here we haven't changed the diagram at all, but we're working with easier numbers. So we can say here we've still got 50 across, times by 4. We've got 200 here,
Okay.
and then over here.
So the area would be 100 for this one.
Yeah, so they're still in the same proportion as what they were before, so it works nicely. And what we can do is work out what k is.
Yeah.
So like the area of this one, we'll go for that one because it's easier, is 100. Okay. The frequency we were asked originally was 100,000, wasn't it? So I can do a quick division and say k is 1,000 or 0.001. And that's quite common, so it makes the numbers easier. Now what we could do is say, right, if we've got any like bar from a histogram, we say, all right, this is the area, which is frequency, and or maybe k times frequency. We can say, okay, well, we know that this bit here is how wide the group is, or class width. And I'll go CW class width. I'm not going to write it, so it's easy to do that. And you've probably seen from GCSE that they used to use frequency density.
I think I've just written FD before.
Yeah, easier. Now we can just make a quick formula for the area here. We can say, well, the area is frequency. So we use capital F. Is that all right?
Yeah.
Okay. Frequency equals frequency density times class width. Okay. So we could rearrange that maybe, or we could put even this k in, couldn't we?
Yeah, I think Mr. Dawson would like that.
Yeah. So we could put the k in and say k times frequency. I don't know, I put a times just down.
Yeah.
And then we can rearrange it because usually we have the frequency, we have the class width, we need to know what this bit is, the frequency density.
That's like the height of the bar, isn't it?
Yeah, exactly, yeah, the height of the bar. That'd be easy to just call it height, wouldn't it? Anyway, k times frequency divided by class width. And that's probably a formula that someone's got written down in their note sheet for them right now.
Yeah, they should probably stick it in their minds.
Stick it in their minds.
Stick it in your mind. Area proportional to frequency. So here we have example one. It's hopefully you have this on your note sheet. A college organised fun run with the times to the nearest minute of the sample shown in the table. And the first thing it asks us is to give a reason to support the use of a histogram to represent the data. Well, the answer to that is a nice straightforward one. It's to do with that really bad bar chart we saw showing the 15 to 65-year-olds and it looking like they were the ones that bought all the cardigans before we used the area. So the answer is nice and simple. The reason we're going to do it is because of these class widths here being unequal, because we have give a reason unequal class widths. So the unequal class widths is a reason to use the histogram. Right, now in part B it says write down the upper class boundary and the lower class boundary of the class 40 to 44. Well, as we see it says the times are to the nearest minute of this sample. So if someone got 42.5 minutes, they'd be in the first block. If someone got 46 minutes 35 seconds, they'd be in the second block. But if someone gets 44 to 45 minutes, say 44 minutes 20 seconds, they're somewhere in between these two values here, this one and this one. And so because the boundaries don't match, we're going to have to put our class boundaries halfway in between. So half a unit lower than 40 is 39.5. The gap is 1 between each group to the nearest minute. So half a unit, half a minute
is 39.5 for the lower class boundary down here. We've got 39.5 as our lower class boundary. And then for the upper class boundary, we're going to do half a minute on. So that would be 44.5 minutes as the upper class boundary. So my lower class boundary equals 40 take away half a minute. So that's 39.5 mins. And my upper class boundary is going to be the top end, 44 plus half a minute. So that's going to be 44.5, put those units on minutes. Right, that was a mark for each of them. Now we've got the main part, the 4 marks, part C, on graph paper, draw a histogram to represent the data. Right, well, I remember that my frequency density is going to equal K times my frequency divided by my class width. So let's have a think about this and let's put our class widths in. Now, to put our class widths in, we're going to need to think about the boundaries because we need to put them in. So I'm going to go ahead and put the boundaries for each of them. So the lower boundary for the next group will be that 44.5, and then the upper boundary will be 47 plus half a unit, so 47.5. Now 48 on its own, well, anything that was 47.5 minutes or more would be rounded up, and anything up to 48.5 minutes would be rounded down. Then we've got 49 to 51, so half a unit less would be 48.5, half a unit up would be 51.5, we've got 51.5 here, and then 55.5 up here, 55.5 here, and finally 60.5 as our upper boundary on the last group. Right, so if I think about the difference there, and I'm going to actually help myself out here, I'm going to make a jot down of all the class widths here. The class widths. So if I go through there, 44.5 take away 39.5, that's going to give me a class width of 5. I've got a difference of 3 between my upper and lower boundary here, and I've got a difference of 1 from 47.5 to 48.5. So that's my class width. Carrying on with that, I've got 3, 4 and 5. Now, I know that area is proportional to frequency, and so K has to be some number to make my data easier. But in a situation like this, well, you know what, I do remember that Mr. Dawson said that sometimes K was 1 and that the frequency did get represented by the area. So I'm going to go ahead and to make my numbers easier to work with, in this situation I'm going to say K equals 1. So my frequency density equals my frequency divided by my class width. So if I add on the other end of this my frequency density, then I've got 10 divided by 5 giving me 2. I've got 15 divided by 3 giving me 5. Then I've got 23 divided by 1 giving me 23, and 21 divided by 3 giving me 7. 16 divided by 4 gives me a frequency density of 4, and 15 divided by 5 gives me a frequency density of 3. I have all the information I need to draw a histogram. Now, intelligent use of scale alert. Notice how I'm plotting from 39.5 to 44.5. On my axes at the bottom where I'm plotting time, I've done it so that each box represents 1 minute. Each box of 5 little boxes represents 1 minute. And rather than put it on 40 and 44, which I see a lot of students do, I've put it on the half minutes so that when I draw my histogram bars, I'll be able to go nicely along my scale. So that's key Mr. Barker tip number 1. Obviously, because it's a histogram, we're plotting the time against the frequency density, so that when I do this frequency density times the class width, I will get the frequency. The area will be the frequency. So my first one is from 39.5 to 44.5. It has a frequency density of 2. So I get my ruler and I'm going to plot from 39.5 up to 2, working my scale out. Each box is worth 2. So one little medium box is 2, so 2 medium boxes is 4, that's 1 big box. So that's 2, and I'm going to go across to 44.5, which will be here. So 44.5 will be here, making sure not to make any mistakes. And there's my first box. Second box is from 44.5 to 47.5 and it has a frequency density of 5. Now that's a little bit tricky. If I know that each medium box is worth 2, I've got 5 teeny tiny boxes in each medium boxes, so I know that 2 divided by 5, well, each one of these is worth 0.4. So to work out a frequency density of 5, I'm going to go up to 4 and then up halfway between 4 and 6, so 2.5 teeny tiny boxes. So let's do that right now. Go up to there and then across to 47.5. Just here. And then at 47.5, we've got our next value, which is 23. This is my tall one. It's only 1 box wide. It's only to 48.5. So go from 47.5 all the way up to 23. Across there is 23, and then it's 1 wide, and I come down like so. Right, let's speed this up a little bit. I've got frequency density of 7. On the next one I'm going from 48.5 to 51.5. So I'm going to go up from 51.5 to my frequency density of 7 and across. Notice when I work backwards, if I go to the end point and plot, I can just draw it back until I have my line. It makes less thinking that way. And then almost at the end, we've got frequency density of 4, 51.5 to 55.5. So I'm going to go along from 4, that's a nice easy one. Along from 4 at 55.5. So that will give me this box here. And then last but by no means least, I've got frequency density of 3. So 3 is halfway between 2 and 4. And that's going to go from 60.5 just here. So that's 2 and halfway up is 3. And that goes across there. Down to 60.5. I've got my time labelled, my frequency density labelled, put a title on, fun, run, times. And I have my histogram drawn. There we go.
Right, let's have a look at example 2 then. Now in this example we're given some information in the table and we're told that a histogram has been drawn and we're given some information about it. So we're told that the class 200 to 240 was represented by a rectangle of width 2 and height 7. So I'm going to draw that out, a picture of what that looks like. So I'm going to draw what the bar looks like. Now this class goes from 200 up to 240 and we're told that it has width 2 centimetres and height 7 centimetres. Now with a bit of thought then it's pretty obvious that the area of this is going to be 7 times 2 is going to be 14 centimetres squared. Right, but let's actually go to where this is in our table. Well, if we look at this, 200 to 240, that has a frequency of 28. And so we've got that the area, 14 centimetres squares, represents 28 people. Now this is just what Mr. Dawson was talking about.
Stick it in your mind. Area proportional to frequency.
So if we take the area and in this case we double it, we're going to get the frequency. So let's use this to find the width and height of this class, 320 to 400. So again I'm going to draw a picture of this bar. And this one goes from 320 to 400. And that is, well, that is a gap of 80 people. So the class width of this would be 80 people wide. Now in this one, a class width of 40 was 2 centimetres wide. So if 40 was 2 centimetres, then we know 80 must be 4 centimetres. Now, we don't know anything about the height because we're not told anything about the height. That's what we're trying to find. So the only other thing we do know is in this group, 240 to 320, the frequency is 22. And so we can work backwards to find the area. Remember that area is proportional to the frequency. So if 14 centimetres squared was 28, a frequency of 28, then a frequency of 22 must have come from an area of 11 centimetres squared. Right, well if we've got the area of the bar and we've got the width of the bar, 4 centimetres, we can work backwards to find the height. So let's just do 11 divided by 4, which is 2.75. So the height must be 2.75 centimetres. So let's make it clear that that's our answer. The height would be 2.75 centimetres. Done.
Right, okay then, so in this histogram we're looking at frequency density here obviously, and we've got speed of car. Policeman records the speed of traffic on a busy road with a 30 mph speed limit and records the speed of a sample of 450 cars. Histogram represents the results. Calculate the number of cars that are exceeding the speed limit by at least 5 mph in the sample. Okay, well that's 35 mph, 5 mph more than 30, so we're looking at all the ones to the right of this line there. Now first thing I'm going to do, I'm just going to see how much area I've got. Now a very way to that is to split into boxes. I've split into boxes like this. Pretty easily. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 2 halves make 22, and I've got another half there, 22.5 boxes. Okay, and that is 450 calves. Okay, well if I divide by 22.5, I'll get that one box. I can use my calculator for this. It's going to be approximately 20 calves. Okay, so I want on my bit that I'm interested in at least 5 miles per hour more than 30. I'm looking at these boxes here, which is 1, 2, 3, 4, 0.5 boxes. So I'll do 4.5 lots of 20, and I'll get 90 cars answering the question. Boom.
Boom.
I'm not the butt of your jokes. Now that'll be the end of it.